Hello everyone, welcome back to another 4D Systems project. Today I will be designing, coding and programming this speedometer on a Gen 4 ESP3250 capacitive touch display using Workshop 4. In this video, I'll take you through the entire process, including designing the UI in Photoshop and programming the display in Workshop 4. Let's get started. For this project, I'm going to start off in Photoshop. I'm just going to quickly run you through how these graphics were made so you can apply this same process for your own graphics, because the way that you build this display and how you export these assets needs to be considered when you are designing your UI to be built in Workshop 4. So this is what the completed UI looks like on Photoshop. Some things on the screen that you see now, where applicable, will be replaced with widgets in Workshop 4. I'll show you the process for that soon, but what I mean is, for example, these numbers here at the bottom next to the labels, trip 1 and trip 2, will be switched out for digit widgets, as it's easier and more practical for them to be programmed using the built-in Workshop widgets. However, for the most part, this is what our final UI design will look like. I'll start by turning off all the layers except the background folder. And as I just mentioned, the numbers that you see on the display now are going to be remade in Workshop, so I'll turn those off for now as well. And this is what we are left with. We have all our labels, this gradient here, and we also have this square fill and the gas icon at the top. These are all of the parts of our display that are going to remain static. And because I know that all of these icons are not going to be animated in our program, there is no need for me to remake them. We can just directly import this onto the form. You can, however, still choose to export these separately as well. You just want to have the freedom to move things around whenever you want. I'm happy with how this looks though, so I'm going to go ahead and export this as its own image. Now that I've exported the background image for the program, the next part of this project is the actual speedometer, or as it's labeled here in the Photoshop file, RPM. As you can see, I have these folders here, and each of them is a frame of the speedometer. So that would be frame 0 going all the way up to when the speedometer has been filled out. If I flick these on and off, you can get an idea of how this would be animated. In Workshop 4, we are actually going to be cycling through these frames, which is how we are going to animate the speedometer. So again, I'm going to export all of these as their own individual graphics. Finally are all of these indicators. These will be implemented in the program using user images. It's the same idea as all the other parts of the program, basically treating the different stages of these graphics as frames. So you can see the different gear indicators here, for example, or for this fuel gauge, there is a frame for each of its stages, which would obviously make it look like it's being filled up. And that is pretty much it for the design part of this project. Of course, things like color and font are all customizable and can be changed depending on the look and feel I would like the design to have. But for right now, I'm really happy with how this looks. So now that we've gone over the UI design and all of the necessary graphics have been exported, we can now head over to Workshop 4 and begin building our project. To start building the program, I'm going to open up Workshop 4, and since we are using an ESP display, I'm going to filter to the Arduino compatible section here, where it says ESP32, and find my display. I'm going to keep the orientation horizontal as well, and click Next. Now you might notice that the usual screen that pops up asking which Workshop 4 environment I would like to use does not show, and instead we are taken to this environment with this orange logo and the file extension for Arduino. This is actually an extended graphics environment specifically for Arduino compatible displays. If you have used the ViSi environment before, it's essentially the same as that, so it's a mixed environment where you can use visual elements like widgets and have full access to the code. Okay, so first thing I'm going to do is just add the background image that I mentioned at the start of the video. So I'm going to click on Form 1, select the image option in the properties, and then click these three dots on the right side. This will bring up a window that will allow me to import my background image. I'll select it from the File Explorer, and now it will show up here. It is scaled properly, so I'll click OK. Then I'm going to navigate to this Properties menu while the form is selected and change the background type option from color to image. Now, as you can see, my image is being displayed and it is linked to the first form. The good thing about doing it this way is that the image is actually locked and will not be affected by anything else that we place onto this form, whereas if you were to use something like just an image widget, it would still be moving around and could possibly interfere with the widgets we are going to place on top. Moving on, I'm just going to add in those numbers that we had here in the original design. If I pull up our finalized design from Photoshop, we had the numbers being displayed next to these labels. So for those, I'm just going to use LED digits. I'll go to the widgets menu, select digits, and then drag in the LED digits. From here, I can customize these as I like. So I can change their color to white, and I can also change the amount of digits they display. This first one, I'll make 2 digits. I'll then copy that over and put it for trip 2 as well. And then I'll copy it over again and put it next to the Odo title, but make it 6 digits. And those are now complete and ready to be coded. Next is the speedometer graphic. So for this, I'm going to break the speedometer into 2 halves, just to make it easier to control and handle when I am writing the code. I'll just drag on a Smart Gauge widget here. Then I'll open the Smart Widgets editor. On layer 1, I will import my frames from 1 to 4 and enable them. Now all that is left to do is give this gauge 5 frames for my 5 images. And that's it. You can now see that when I scroll through the frames, they are being cycled through and the movement is clean. It is that simple to animate this speedometer in Workshop 4. Because the Photoshop file was set up properly, it makes it super easy to be able to implement the graphics into the program. So now that that is working, I'm basically going to follow the same process for the rest of the speedometer. I'll show you again. I just need to drag in a Smart Gauge, open the Smart Widgets editor, and import the rest of my images and make sure that they are in the correct order. Then I'll enable the layer that they are on. This time we need 6 frames, and there you go. This gauge is also working. So now if I just line these up nicely, you can see that our speedometer graphic is complete, and when they are animated, they will be working together. Because we will only ever have 1 frame shown at a time, they will not interfere with each other. For example, frame 1 of this gauge on the left and frame 1 of the gauge on the right cannot be shown at the same time. So on the display, the user will not know that these are 2 separate gauges. The last Smart Gauge instance is going to be to display the numerical value, so the kilometers per hour that goes under the speedometer graphic. This one is also very simple. We actually don't need any graphics for this at all. I'm again going to drag in a Smart Gauge, and all I'm going to do this time is activate this option here for the numeric value. This option is basically going to show the exact value to be displayed depending on the range that I give this widget. So for example, if I set 120 frames here and scroll through them, you can see that now depending on which frame I am on, a number is being displayed. And in this case, I think 120 is enough, so I'll leave that as is. The last thing I'm just going to do is change the font and scaling of this Smart Gauge. So those are all of our Smart Gauges finished. The final widget type that we'll be using for this display is User Images. User Images basically allows you to upload multiple images at once and again treat them like frames. So it is a similar process as what we just did with the Smart Gauges. However, with something like the gears, we only ever want one to be displayed at a given time instead of having this continuous graphic where we are moving from one part of the animation to the next. So I'll start with the gear changer, which is going into this grey box on the right side here. I'll go to the System Media tab and drag in the User Images widget. And then I will choose the Images option over here in the Properties. This, similar to the Smart Widgets editor, will allow you to upload multiple images into this one widget. So I'm going to select my images and press Open on the File Explorer. And now you can see that we have these uploaded and they are being displayed on my preview screen. However, as I mentioned, only one of these will show up at a time, so we will add some code in later to cycle through them. Now that that is done, I'm going to repeat these steps for the rest of our graphic images. That includes the fuel meter at the top, the indicator arrows, and the light graphic over on the right side. Again, I'm simply importing all of my images for the sequence into a user images widget. And that is pretty much it for the UI design side of things. Next is to go onto the coding. The coding for this program is relatively simple, but I will run you through it as I am typing it out, just so you have a good understanding of what is happening and how we are controlling all of the widgets that are placed on the screen. I'm using the GFX for the ESP32 library and running a loop animation sequence. So for example, this section here is our user images. Then for our smart gauges, we are sweeping smart gauge 1 between all of the frames and locking it, while smart gauge 2 is active between frames 0 and 6. This is what's going to give us that clean continuous motion that we want for this gauge. And here at the end of the code, we are of course also animating our LED digits as well. And that's all for the program of this code. It's really simple. So now that we have finished our design, imported everything that we need for our program, and completed the coding for the project, I can compile and upload the project, and the working animated speedometer will be uploaded to the display. That's all for this project. An easy and fast way to import your own graphics, animate them, and have a complete and custom design display. I hope this video was helpful. If you would like to check out the ESP display range used in this video, please check out the 4D Systems website at 4dsystems.com.au. If you have any other questions, please head over to the 4D Systems Resource Center, and don't forget to subscribe and stay tuned for more tutorials.